Okay, for today, this is the number one thing that's going to burn you guys on the next test, is you're not going to look for a GCF. I'm not sure you're even knowing what I'm talking about yet, but I will explain. So imagine for a moment that you've just factored something, or let's say you're even in the middle of factoring something, and you're like, man, these numbers are really hard to work. It's hard for me to figure out what to put here and here. I know it's got to be plus and plus because of the signs here, and I know it's got to be a 1 times a 2 because that's the only way to make a 2 with multiply. Okay, but if you're struggling with it, you should look and see before you even go into the problem. Do you see that they all have a 2 in them? That's called factoring out the GCF, and that's what you're going to forget. It happens all the time. People get good at factoring even. In honors, kids, happens all the time in honors too, where you don't notice that there's a 2 in everything. So what if there's a 2 in everything, Mr. Server? Well, let me show you. If there's a 2 in everything, you take it out. And when I say take it out, I mean you put it out in front, and then you put a parenthesis like this, and then you divide them all by 2. Just watch me. You don't have to do anything. You divide them all by 2, and that tells you, 2 over 2, I guess it's just 1x squared. 4 divided by 2, I guess that's plus 2x. And 2 divided by 2, I guess it's plus 1. And then do you get that I've got the GCF in the front? And that's really, really common for people to forget that. Do you get I just took a 2 out of all of them? They all had a 2 buried in them. And I took it and put it in the front. And if I multiplied this back out, I would get my original problem. All right, and then if you were on my actual next test, the final step of this would be to go 2 stays there, 2 parentheses. This has to be an x and an x, because that's the only way to make an x squared. It has to be a plus and a plus because there's only pluses in the problem. And then what multiplies to 1 is 1 times 1. And then I factored it. All right, so that's a big picture of what you're going to do on factoring. That's like one of the hardest problems for today. They're actually really easy factoring. And if you know that you've seen factoring and you know you've always been bad at it, this is your chapter to get it down. Because number 1, that's all the next test is. It's like 12 factoring problems. So if you don't get factoring, you're going to die on the next test. And factoring is the number 1 thing. I've mentioned it multiple times. If you can factor it, you should, is my favorite saying. And factoring is the thing that comes up in pre-calc. Some of you don't take pre-calc until 2 years from now. But you're all going to probably take it before you get done with high school. That's pretty much the minimum that they want, is that you are through pre-calc by the time you are out and you're in college. So they want you to finish pre-calc in high school. Now, some of you won't get that far. There's a few seniors that are in here right now that won't get the pre-calc until college, but then you'll probably take it in college. But ideally, you all take pre-calc, and in pre-calc, it's all factoring. Like the hardest stuff is because you got to factor. So you've got to learn this now. If you've never learned it before, you got to learn it. So it boils down to, this is factored already. It's like the answer to the question. But you really have to know how this works when you multiply it out. This was on our last test where you had to multiply this times this and that times that. Would you please take a second and multiply this one out? That is a fundamental underlying skill. Some kids use FOIL. Other kids just distribute twice. You get 4 parts. Stay with me. Gotta be able to multiply stuff out. Multiply it out. The x times the x makes x squared. The x times the negative 9 makes negative 9x. There's my first distribute. 2 times the x, 2x. 2 times the negative 9, negative 18. Put it all together. X squared, these two make negative 7x minus 18. Raise your hand if you had that one right. Awesome. That is key. Sam, did you have this one? Okay, good. Then, one more reminder. If this thing equaled 0, then I could do something else, and that's called find the zeros, or find the roots, or find the x-intercepts. If it said equal 0 on our last test, do you remember the deal where we would say, oh yeah, 9 would make this thing equal 0. So that's, I just set y equal to 0, so that's an x-intercept. 9 is an x-intercept. And so is negative 2. Do you remember that? Well, that's still in this chapter too. On our next test, you got to do that again, except this time, we're finding something called the zeros. So you just say x equals 9. Because see, if x equals 9, it will equal 0. And that's not an x-intercept because it's not on a graph. Do you think you can make that shift? See, last time I was telling you have to write it as 9, 0. On this test, you have to write it this way because it's not an x-intercept anymore. Here it's a solution to an equation. It's what makes the equation 0 this time. I know it's a lot like what we just did, but you have to answer differently because it's technically a different question. Okay, that's all for one slide. Everybody get to this. Do you know what the GCF of 15 and 25 is? A way to say it is, what is a factor that goes into both of them? 5. Now, is that the biggest thing? Yes, in this case it is. I'll give you an example. 1 also goes into both of those. But it's not very great because it's not very big. And so 5 is the GCF of those two. What's the GCF of those two?
4.
Yeah, because 4 goes into both of them. A little more tricky. What's the GCF of those two? You might look at the numbers and go, there's nothing that goes into both of them. That's true for numbers. Take the headphone out if you would, please. Thank you. But for the variables, there we go, good. For the variables, there is an x in both of them. So then the GCF is x. They both have an x in them. So x is the GCF.
So we ignore that third?
No, you're not ignoring it. You're just saying this has an x and another x and another x. This one's only got one x. So what do they have in common? Just one x. You couldn't say x squared, for example, because they don't have two x's. They only have one x in common. All right, on to the next page, please. So these freak people out because they're like, but I can't make two parentheses because there's no last number and it's so different. And you're right, you do have to do it different, but you're just looking for the GCF. Do they both have a 2 in them? Yeah. Do they both have an x in them? Yeah. So you take out a 2x, put a parenthesis, and then remember what I told you. You're dividing by 2x on both of them. That's how you figure out what's in here. Even a small child could figure out that they both have a 2 in them and they both have an x in them and could put that here. But can you finish it by figuring out what goes on either side of the plus? That's why you put the 2x on the bottom so you can go, oh, the 2's cancel. And you're supposed to know by now if there's xxx on the top and 1x on the bottom, that x squared is what's left. And these two, 4 divided by 2 is 2. X divided by x, they cancel. They reduce to just, technically there's a times 1 there, but 2 times 1 is just 2, so. Now how do you know if you're right? Let me just show you how you can know if you're right. I just have to go this times this, and this times that, and then I will know I'm right. Because 2x times x squared is 2x to the third. That's what I started with. And 2x times 2 makes plus 4x. And that's what I started with. One of the cool things about the factoring test, listen close. You can check every answer. You will know if you're right. Because if you factored it right, when you multiply it back out, you'll get the original problem. Do you see how you can check every single problem? Now sometimes it's true that they're so hard that even though you can check it, you never figure out what it is. But if you think you have an answer, like if I thought this was the right answer, and it's close, but it's not right. If I thought this was the right answer, I could check. I go this times this, and doesn't make 3x to the fourth. So then that can't be right. See what I mean? You can check them. So this next test is not only super important, you can know when you walk out of the test whether you got problems right or not. And so you could know, I only got 2 wrong on the whole test, therefore I probably got an A on that one. Because you can just multiply it back out. Some kids don't, and that's really dumb, because you could know ahead of time that that answer was wrong. All right, I'd like you to try this one right here. Figure out what the GCF is, the greatest common factor, and put it out in front of a parenthesis. Shouldn't have to give you a private invitation to do that. Well, I think everybody's going to notice that they have a 3 in both of them. But I think some people are going to just think it's 3x. 3x squared, very good. Zane, you know that there's a plus in there. I know you know that. But let's say there's a kid who doesn't know how to get these two. Don't just tell me these answers for here and here, but tell me how they're supposed to get them. I'm going to say it this way. They're supposed to put 3x squared here and 3x squared here so they can see that goes there. That's what they're supposed to do. So Bennett, now that I've done that, can you tell that those cancel? And then what's left here that I should put here?
X squared.
Yep. Now, it's true that this times this makes that, but that's not always the best way to get it. This, where you divide it by the thing, that's the best way to get it. Maura, could you tell me what that simplifies to right here? This right here?
Okay.
Oh, I'm sorry. In the front row, Mara, H. 3. Because these cancel each other, and 9 divided by 3 is 3. Yes. Now, if I wanted to be sure, because my grade was riding on it, and I was like, okay, I only have 4 hard questions on the test, I suppose I should check it. I would go this times this, and I get 3x to the 4th. And was that how I started with? Yes, it is. And then I do this times this, and that would make 9x squared. Is that what I started with? Yes, it is. I know I'm right now. Okay, so that's factoring. Let's move on. Find this page, page 4. This is kind of your classic. They don't have a GCF, so you don't have to factor anything out to the front. So then you just go into 2 sets of parentheses. Henry Nichols, what has to go here and here?
X.
Yep. That's the only way to make an x squared is x times x. Marshall, what signs do I have to have? Yeah, they both are pluses because there's only pluses in the problem. If there had been a minus in the problem, I would have started with a minus. Because if there's ever a minus in the problem, then there will be at least one minus. So I'd always check for that, see if I should make it minus or not. All right, next step is a number goes here and a number goes here, and listen close. Some of you were taught wrong. Some of you were taught they were going to multiply to this and add to that. That isn't always true. They will always multiply to 12 though. Just think about that. Don't think about the whole multiplies to 12 and adds to 8. That only works sometimes. And something that only works sometimes is not very good. Like if you had a bow and arrow, and sometimes it worked, and sometimes it just snapped in half. Like every other time it didn't work, you'd be like, oh, I'm not using that thing. It's going to kill somebody from arrows flying all over the place. My point is you want to trust your math that you can always do the steps that you expect. I expect it to multiply to 12, and I guarantee you it has to multiply to 12. But it won't always add to 8. I know some of you think it does, and that I need to break that. It won't always add to 8. It will always multiply to 12. So I'm thinking 4 and 3 multiplies to 12, and that's true. This is what I checked, that and that. And that makes 7x, and that's not 8x, so that was the wrong choice. 3 and 4 didn't work. I tried. How about 6 and 2? 6 times 2 makes 12. And I know some of you are like, but see, it adds to 8. Yeah, sometimes that's true. But sometimes it isn't. And on your test, I guarantee you that at least 3 times on the test, it won't add to 8. It will always multiply to this. But on your test, I'm warning you, it doesn't always add to 8. It always multiplies to 12, though. Okay, moving on. This one. They've got 2 different things, but it's the same problem. What the heck? Well, one of them says to factor it, and then that means all you got to do is factor it. Like half your test, all you got to do is factor them. But on the other part of the test, you have to solve it. Hint, it starts by factoring. So on both of them, you would just factor it. So let's get this factored. Henry Kist, what has to be here and here? Yep. Now, use logic and tell me what this first sign should be. Plus or a minus, Mr. Kist? Minus. Now that we know there is a negative in the problem, there must be a negative in the answer. The next question is, could they both be negative? Yes, because a negative times a negative makes a positive. See? That's why I knew this had to be a minus again. There had to be one negative because there was a negative in the problem. There had to be 2 negatives because a negative times a negative makes, this is what they multiply to, right? And how would you get it to multiply to positive 3 unless there was 2 negatives? Okay, and then it's got to be, well, remember, multiplies to this. It's got to be 3 and 1. 3, 1. Done. That's it. If I was not sure, I'd multiply it out, but I'm positive, so I'm good. All right. Well, on this, how is it different? Because they didn't say to just factor it, they said to solve it. And that means you got to get the answers, which are x equals 3 and x equals what? 1. Now, last time, I made you write it like this. Why is it different this time? I don't want this. Because last time, I was asking you for x-intercepts. Do you say anything on here that says x-intercepts? No. They ask you to solve it. That means what's x? And x is 3, and x is 1. And if you haven't ever figured this out, the reason that works is because if you put in a 3, it will actually equal 0. And if you put in a 1, it'll actually equal 0. That's why they're called the zeros or the solutions, and that's what you get when you solve. So notice how I wrote them. It's just torture. On the last test, there was probably 8 kids that got it wrong because they didn't put comma 0. Warned you so many times. On this test, there's going to be like 8 kids that don't write it this way. Just now, don't be one of them. All right. One more thing. We're going to give you this for the test. Why? Why is that any better than a calculator? Because if I give you the number 24, and you want to know that the factors are, with a calculator, you got to go 24 divided by 2, 24 divided by 3, 24 divided by 4, 24 divided by 5. Ooh, doesn't work. 24 divided by 6, 24 divided by 7. Ooh, didn't work. 24 divided by 8. See what I mean? It's such a pain. But here, if you want the factors of 24, you go, there's a 24. Can you tell it's 12 times 2? See what I mean? So if you're trying to figure out what the factors of 24 are, you just look for 24s on your chart. See any more 24s? I do. Ooh, so 8 times 3 makes 24. Now, you'll still have a calculator, but we just think that this is easier. 8 times 3 makes 24. So again, why would I need to know? Well, because what if your problem was this? X squared plus 6x plus 24. I'm not giving you this problem right this second. I'm just showing you. You'd have to figure out things that multiply to 24. And there's tons of them. And we're going to give you one of these because it's easier. Here's another one. 6 times 4 makes 24. Here's another one. 4 times 6. All depends on what order you say it in. But the point is, you'll have one of these charts, and there's all the ways to make a 24, and it'll be way handier than a calculator. All right. Then using this chart, if I was looking for ways to make 12, would you please circle all the 12s you see on the chart? It won't take you very long. Just circle all the 12s. And in the real world, on the test, you would not be forced to circle all the 12s. But you'd go like, oh, I guess 12 and 1 is a way to make 12, and you could check and see if the factors work, and then you're like, 12 and 1 didn't work. Then you got to look for another 12. Ooh, I could do 6 and 2. Ooh, I could do 4 times 3. Or, see this yellow dividing line? See across there? Then all the 12s you have are just going to be the same thing but reversed. Like 12 times 3. Know what I mean? 6 times 2. There's the same thing. They're just reversed. Instead of 2 times 6 is 6 times 2. So really all you have to do is look on one side of that yellow dividing line. All right, move on. You notice there's a little multiplication chart right there? All right, tons of kids are going to get this wrong because they don't find the GCF first. Would you please find the GCF first? Get that factored out. Zane, what do you think goes into both of them? 3x. Everybody that didn't figure that out, do it now. Bennett, what am I supposed to put right here and right here to see what goes here and here?
Minus 3x.
You're close.
3x.
3x. Then this will tell you what goes here. What is 3x squared divided by 3x? It's just x. The sign just stays the same. That's super simple. And then what's 9x divided by 3x. Well, the x's cancel. It's really just 9 divided by 3 is 3. There we go. Raise your hand if you had it right. Awesome. If you tried to factor that with 2 sets of parentheses, you would have been really lost. That's why I started this whole thing with look for a GCF. Now, the only difference here is they say solve, and it's the same exact problem. Oh, yeah. Then I just have to figure out what makes that 0 and what makes that 0. X equals 3 is one of your super simple answers. This one trips people up for some reason. I don't know what it is. But what would be you able to put right here that would make the whole thing equal 0? 0. Just 0. I think people think you have to like make it equal 1 or something, and they'll put an answer of 1/3. Or they'll try to take 0 divided by 3 or something weird like that. It's just 0. The answer is just 0. X equals 0 and x equals 3 are my 2 answers. Those are my solutions. Okay, we're on the last page. Last page. Back to this. You shouldn't need my help. Dig in. Get this. Kiri, you can do this. Problems on the board. If you didn't already notice the 2 and everything, notice it now. Then notice you can factor it again. See, the 2 comes out. It doesn't mean you're done with the whole problem. That means you divided everything by 2. And you got x squared plus 8x minus, what's 40 divided by 2? Ooh, half of 40, 20. And it can be factored again then. It's like 2 factoring problems in 1. Like that. So do it 1 step at a time. Caden, do you agree they start with x's?
Yeah.
Okay. Do you agree that there's a minus in the problem?
Yeah.
Now think it through. Can it be 2 minuses or not? It's either a yes or it's no.
Yes.
Because why?
Because
Negative times a negative makes a negative?
no positive.
Okay. So it has to be plus. Daniel, last numbers. They have to multiply to 20. Now, I could look them up on the chart, or maybe you know some. Daniel Kurth. 10 and 2. You're thinking in terms of making that 8 work, and I think you did it right. I will check, though. Now, if it hadn't worked, I would switch the 2 numbers around or switch the signs around. All right. This I should multiply this out with the first outside, inside, last. The first is going to make x squared, though. So listen close. When you're checking, save yourself some time. And always check what I call the smiley face of factoring, which is this and this. See how it kind of looks like a big smiley face? That's where it's always going to make the difference on the hard factoring problems is do those 2 make that? Does 10x minus 2x make 8x? Yeah, it does. That's how you can check. You check with the outside ones and the inside ones. That's what's going to usually get you, is you may not have multiplied those right. Because that plus that needs to make that. And it does. All right. So, assignment is a factoring. We're not doing this one. It's okay. We're ready for the actual problems. So there is a sheet right near the notes that is the problems. And then there's I'd like you to split screen, and I'm going to walk around to make sure you learn this, because for our entire unit, we're going to be doing it like this. The PDF is going to go on one side of your iPad. The Schoology quiz is going to go on the other. That way, you can do the problem out on this one half of your split screen, and then you can type the answers into the Schoology quiz on the other half. You get what I mean? The problems are on the PDF, and then the Schoology quiz is where you're going to type them. So get that up on your iPad right now. You're going to get a split screen where one side is the questions. It's a PDF. And the other side is the Schoology quiz. If you haven't learned how to split screen, this is the time where I need to teach you. All right, I'm going to pause for a second while I check those. Let's just do that first one. Bennett, would you just read problem 1 to me?
X squared plus 5x minus 14.
That didn't sound like Bennett's voice, but I'm glad I got the problem. Okay, now to actually factor that, I go x, and do you see a minus in the problem? Therefore, there must be a minus here. Do you see that you can't have two minuses? Otherwise, a negative times a negative wouldn't make a negative. That has to be plus. Then last step, Zane, how do I make a 14? Now, I'm going to not be sure whether this is right. 7 and 2. So watch. I check it like this. Remember the smiley face of factoring? 2x negative 7x, does that make a total of 5x? No, it doesn't. And now listen close. If it ever makes the opposite of what you wanted, see, this comes out to negative 5x, then you change the signs, not the numbers. Now, I know some of you are going to be like, I changed the numbers and it worked fine. Trust me later, when you get the opposite of what you want, change just the signs. Because when we do the more complicated ones, that will always work. Do you get always works is way better than sometimes works? Sometimes switching the numbers would work, but switching the signs to get the opposite answer always works. Okay, good. Then, do they actually ask you for the solutions on this one or just to factor it?
Just factor it.
Okay, good. Then you just got to type that, and you're good on number 1. If they asked for the solutions, they would have been x equals negative 7 and x equals 2. But they didn't ask us for that this time. All right, I think you got the idea, and that's all I got for you for today.